lecture is pertaining to the polymer processing, that is methods of spinning for additive manufacturing. Wet spinning. The first one is wet spinning. Wet spinning is required for polymers that acquire dissolving in a solvent to be spun. Being extruded into a liquid provides a greater drag force on the filament than those extruded directly into air. Therefore, the speed at which this occurs is reduced from that of melt and dry spinning. Once evaporated, these fibers then have to be drawn or stretched in order to orient the polymers to give fibers its strength. The fiber solution is extruded into a liquid that will draw out the solvent, leaving behind only the polymer. The rate at which this occurs is crucial, as if it occurs too quickly, the bath liquid can create micro voids in the fiber, which will be a weak point. Wet spinning is based on the precipitation, where a polymer is drawn through a spinning wet spinner or spinneret into a non-solvent. The prepared spinning dope is extruded into the non-solvent and precipitation or coagulation occurs. Now, the dry spinning. In dry spinning, the polymer is dissolved in its solvent and then extruded. As the fibers emerge through the spinneret, the solvent is evaporated off with hot air. In most cases, this is then collected and reused. Figures illustrate the process. Dry spinning is required for the polymers with a melt temperature equal to or close to their thermal degradation temperature. Therefore, they require dissolving in a solvent in order to be processed into the fibers. Now, about the biopolymers. It is a polymer that is developed for living beings. It is a biodegradable chemical compound that is regarded as the most organic compound in the ecosphere. The name biopolymer indicates that it is a biodegradable polymer. This polymer has been present on the earth for billions of years. It is older than the synthetic polymers such as plastics. Some biopolymers examples are proteins, carbohydrates, DNA, RNA, lipids, nucleic acids, peptides, polyarchates, or glycogen, starch, cellulose. Now, classification of biopolymers. There are four main types of biopolymers. They are the sugar-based polymers. Starch and sucrose is used as input for manufacturing. Polyhydroxybutyrate sugar-based polymers can be produced by blowing, injection, vacuum, forming, and extrusion. Lactic and acid polymers, polyacidics, are created for milk sugars, lactose, that is extracted from the potatoes, maize, wheat, sugar beet. Polyactides are resistant to water and can be manufactured by methods like vacuum forming, blowing, and injection molding. The second category is starch-based polymers. The starch acts as a natural polymer and can be obtained for wheat, topeka, maize, potatoes. The material is stored in its tissue of plants as one way of carbohydrates It is composed of glucose and can be obtained by the melting starch. This polymer is not present in the element tissues. The third one, that is biopolymers based on the synthetic materials. Synthetic compounds that are obtained from petroleum can also be used for making biodegradable polymers such as aliphatic, aromatic, and copolysters. Though these polymers are manufactured from synthetic components, they are completely compostable and biodegradable. The fourth category, that is cellulose based polymers. These are used for packing cigarettes, CDs, and confectionery. confectionery. These polymers is composed of glucose and is the primary constituent of plant cellular walls. It is obtained from the natural resources like cotton, wood, wheat, and corn. The production of biopolymers may be done either from the animal products, or agricultural plants. Thank you. If any questions, please clarify.